the most important characteristic of an entity is the primary key, which uniquely identify each entity instance. So primary key, as we know, that sometime it is a single attribute, or sometime it is two or more attributes, combination of two or more attribute. Now, what is the primary function of the primary key? Its function is to guarantee entity integrity. Plus, primary key and foreign keys work together to implement relationships in the relational model, because when we map our entity into the tables or relations, then we use primary key and foreign key concept together just to show the relationship among different entities. And it is very important to select primary keys properly, because it has a great effect on the overall our database design model. Okay, when we talk about the concept of unique identifier, so it is commonly we encountered it in the real world. Like for example, you use class or section number to register for classes, or invoice number to identify a specific invoice, or account number to identify a specific account. So these examples like account number, invoice number, or a section number, these are some of the examples of natural identifier or keys. So a natural key or natural identifier is a real world or generally accepted identifier which you use every day, and it is having this characteristics of uniquely identifying the real world object. So as its name said, that a natural key is already familiar to the end users and make a part of their day-to-day business vocabulary as well. Like you are already encountering these attributes in your day-to-day business. Usually if entity has a natural identifier, then a data modeler will prefer to use that as a primary key, because natural identifier are the best candidate for the primary key, and most natural keys are acceptable as primary key identifier as well. If there is no single attribute that can work as a primary key, then you can use composite primary key or surrogate key as well. As we know that a primary key is that attribute, a single attribute or combination of attribute which uniquely identify entity instances in an entity set. But the primary key be based on, say, let's suppose you create a primary key consist of 12 attribute. Now how long can a primary key be? This is not a good idea. Like if you are using composite primary key or combination of multiple attribute to choose a primary key, then you should not take all the attributes of the table as a composite primary key for that table. It is not a good idea. Okay, the main function of primary key is uniquely identifying an entity instance or a row inside a table. So in particular, given a primary key value that is worked as the determinant, so the relational model can determine the value of all dependent attribute that describe this entity. So we can say that primary key guarantee entity integrity, but not to describe the entity. And as I already explained, that primary key and foreign keys are used to implement relationship between entities. So the implementation of such relationship is done mostly behind the scene, or we can say it is hidden from the user. Like in the real world, end user identify object based on the characteristics of the object. Like for example, when you are shopping at a grocery store, you select product by taking them from a shelf, and then you can read the label not by looking at the stock number. Okay, if the stock number is the primary key of that object, you are not going to look at it. You just look at the label and you will select it from the shelf. So it is wise for database application to copy this human selection process as much as possible. Therefore, database application should let the end user choose among different descriptive narratives of different object when they are using primary key values behind the scene. Okay, so here in this table we list some of the desirable properties of the primary key. First property, that attribute should be chosen as a primary key which has a unique value. Unique value mean its value should not be repeated for any of the occurrence of entity or any entity instance. Okay, it should be unique. First main characteristic is it should be unique and it should not contain null value. It is not possible that primary key value contain null. Okay, very very important. It should not contain null and it should never repeat itself. Always a unique value. Okay. Second characteristic is it should be non-intelligent. Now what it means by non-intelligent? It means that your primary key should not have some meaning other than that it is uniquely identifying the entity instance. Like, you know, if we are choosing a primary key for a student, so we will choose student ID as a primary key instead of student first name and last name. Why? Because student ID is a number and this number has no meaning in it. But if we are choosing student first name and last name as a primary key, it has a meaning in it. It shows that this particular record belong to this student. Okay, no change over time. Now third characteristic is we should choose such type of attribute as a primary key which should not change over time. Like same example, for student table we are choosing student ID as a primary key instead of student first name and last name, because if we are choosing student first name and last name as a primary key, like here they give an example. Okay, primary key is the student first name and last name Vicky Smith, and now Vicky got married, and after getting married she changed her name to Vicky something else. So it means primary key value has been changed. So we have to make this change, not only that particular record of Vicky Smith where we are using it as a primary key, but also because we are using this primary key as a foreign key in so many other tables, so we have to make changes into all those tables as well. So in short, we can say that primary key should be permanent and unchangeable. It should not be a such attribute which can change later on. Okay, preferably single attribute. Yani wherever possible we should choose only a single or one attribute as a primary key. We should not go for the idea of composite key. Composite key you should choose only when you do not have any attribute which satisfy you cannot have a single attribute which satisfy the criteria of primary key. But wherever possible we should choose single attribute as a primary key. We should not go for composite key. Preferably numeric, yes, because as we know that we want our primary key to be unique, and unique value can be better managed when they are number, because database can use its internal procedure to implement counter style attribute that like, you know, you do not find any preferable attribute in any table as a primary key, so you can add your own, you know, special attribute over there in the database as a primary key, single attribute, and then ask database to increment its value every time when a new row is inserted into this table or when a new record is added into this table. So numeric is always preferable. Okay, security compliant. And now again, your primary key must not be consist of any attribute which consider the security or privacy risk. Like, you know, if you are using a social security number as a primary key, it means that if it has been compromised, somebody can get it, and it is not a good idea to use social security number as a primary key in employee table, because it represents a lot of information about the employee, and it's a security or privacy risk. Okay, we have seen previously that one of the attribute for the primary key is that we prefer to select single attribute as a primary key, but it's not the case that or it doesn't mean that composite primary keys are not allowed in a database design model. In fact, you can choose composite primary key particularly in these two cases. It is useful to choose composite primary key. First case is when you are implementing many to many relationship, and you know that in order to implement many to many relationship, you have to add a new attribute over there, and for that new attribute the primary key is a combination of both of the other attributes, which are like, as a relationship you will change many to many relationship, that relationship as a attribute, and for that relationship the key is primary key is always a composite primary key, which is the foreign key and primary key at the same time in that table. Or when we are using weak entities as an identifier for weak entities, because in weak entities which have a strong identifying relationship with the parent entity, we need to add the primary key of parent entity as a part of the primary key of the weak entity. So in that case your primary key will be a composite key. Okay, here we have an example of many to many relationship between student and class. So we implement this many to many relationship between student and class through adding a new entity, enroll, over here, and enroll is in one to many relationship between student and class. So this new entity that we add over here, it is a composite entity identifier, and here in this entity its primary key is composite primary key because it consists of two attributes, class code and student number. Class code is the primary key of class and student number is the primary key of student. So in that case, yeah, it is allowed to use composite primary key, or it is useful. And same is true for weak entities, like employee has dependent, so dependent is the weak entity, so dependent primary key is not only dependent number but also employee number. Okay, there are some cases where primary key does not exist in the real world, or the existing natural key might not be a suitable primary key. So in these cases we use a standard practice to create a surrogate key. So we use surrogate key in that case when there is no natural primary key exist, or you choose a candidate key to work as a primary key which has some embedded semantic content or some meaning into it. Like we see that one of the characteristic of the primary key is that it should not it should be non-intelligent, but we do not have such key exist in the table. Or selected candidate key is too long. We have select candidate key to work as a primary key, which is a composite key and consists of so many attributes. So in that case we said that, oh, this is not good idea to choose this candidate key as a primary key. We should go for a some other option. So that option is using the surrogate primary key. Okay, what is a candidate key? Candidate key is the attribute. First you choose some attribute and see that whether this attribute work as a primary key or not. So candidate key is those attribute which you choose to see that whether they are suitable to be used as a primary key or not. So you select candidate key which has embedded semantic content, or it is too long, or there is no natural key that work as a primary key. So in that case we go for surrogate primary key. Okay, surrogate key is like, like an index that you use, or ID, or a number that you use, and for every new record you just increment it. So we can say that surrogate key has no meaning in the user environment. We just add it to distinguish one entity instance from another. And because it has no meaning in it, so we can generate it by the database management system, so that we make it sure that its value is unique whenever we use it. Okay, like for example, we have this table which is used to keep track of the events. So in this table, if you see, we have different attributes: date, the time start of the event, time end of the event, room in which event is going to occur, event name, and party consists of how many person, let's suppose. So if we have to choose the primary key of this table, so possible primary key can be either we can choose date and time start and room. Okay, so one of the possible candidate key for this table is date, time start, room. Another possible key for this table can be we can say, okay, I will highlight in different color: date, time and room. Okay, date, time and room. So we have two possible candidate keys over here. One is date, time start, room, or date, time and room. Now you can see it is a composite key, and composite key that consists of 3 attributes. Now let's suppose we have another table which keep record of the resources, like each event may use resources. So we have one table, this table is related to event, and then we have another table which is related to resources. So when we have this resource and event table, they have many to many relationship with each other. So in order to solve this many to many relationship, we create another composite entity, event resources. And then event resources, because it is added to solve this many to many relationship problem, so it will have the primary key of event table as well as resource table. So the primary key will be date, time start, room plus resource ID, let's suppose, for this event resource table. And you can see that now it consists of 4 attributes. And now when we add this into some other, it has a relationship with some other entity, again it will increase the complexity of this primary key, and primary key consists of so many attributes. So in that case, we said that it's not a good idea to use these candidate key as a primary key. Why not we choose a surrogate key? Now surrogate key is what you add over here, just one attribute, and you call it event ID. Okay, event ID, and you use this attribute event ID as a primary key of this table. And this event ID attribute is just added by database, and every time when new row is added into this table, this event ID is just increased by 1. So we make sure in this case that it is always unique, like first is 1, then 2, every new row it will be increased by 1, 1, 2, 3, 4. So this event ID will become what? It will become the surrogate key of this table. Okay, now we will have some design cases where we will discuss how to map your ER diagram or ER model to relational model, because we know that each entity will map to a table, and then when we map it to a table, the relationship between entities is represented through foreign key concept. So how can we do so? We will discuss it over here in different use cases. Data modeling and design require skills which you get through experience, because when you go through different database designs with passage of time, when you have more experience with so many different type of use cases, you will be more experienced with it and expert and become expert. And there are 4 special design cases that highlight. One is what is the importance of flexible design, proper identification of primary key, and placement of foreign key. Okay, in order to properly implement the relationship between entities, we use the concept of foreign key when we map our entities into a relational model. So first use case that we will see, that if 2 entities are in one-to-one relationship, then how can we show this relationship in relational model, or when we map our entities into the table. So there are 2 options. First option is place a foreign key in both entities, and it is not a recommended solution. Okay, like here for example, we have employee and dependent, and employee and dependent are in one-to-one relationship with each other. So the first option is we can place department ID as a foreign key in employee table and employee num as a foreign key in the department table. But they said that this is not a recommended option. Why it is not a recommended option? Because it duplicate work and it could conflict with other existing relationships. So they said that it is not recommended to put each primary key in the other table as a foreign key. So the second option is place a foreign key in one of the entities. Now, okay, either add in employee table department ID as a foreign key, or in the department table employee num as a foreign key. Now, in which table we have to add a foreign key, whether in employee table or a department table? Now, the answer of this question is based on these rule. Okay, if in case one side is mandatory and other side is optional, like here in this example, we can see that employee is mandatory to department, but department is optional to employee. How can we say employee is mandatory to department? Because of this, it shows 1 1, and here it shows single line and 0. It means department is optional to employee, but employee is mandatory to department. It is possible there is a new department and it does not have any employee right now. Okay, but whenever there is a employee, it is mandatory to department. Okay, or okay, so it is one side is optional and one side is mandatory. Now if one side is optional and other is mandatory, so as per rule, place the primary key of the entity on the mandatory side in the entity on the optional side as foreign key. So here we will place the primary key of mandatory side. Mandatory side is employee, so primary key of employee table, that is employee num, as a foreign key in the department table. Okay, you can see here employee num become the foreign key in department table as per this first rule. Okay, the other case is both sides are optional. So if both sides are optional, then select that foreign key which cause minimum null value, and or place the foreign key in the entity in which relationship role is played. Okay, or a third case is if both sides are mandatory. So for this, again they said it will be same as case 2, or consider revising your model to ensure that 2 entities do not belong together in a single entity. Okay, if you want to maintain history of time variant data, like you have some attributes in the table whose values might change with the time, like employee salary. So employee, whenever he has an increment, his salary will change. Okay, first year salary is different, next year salary is different. But if you want to keep a history of the data that has been changed, in that case, if you like replace every time when a employee salary change with the new value, you cannot keep record of the employee's salary, what was his salary in year 1 or year 2. You just have the current value in your database. But if you want to keep record of the history of data change, then you will deal with this in the same way as a multi-valued attribute. And you know that when we have multi-valued attribute, what we do is we create a special entity out of that attribute, and then we create a relationship with the parent entity with one-to-many relationship. So same is the case here. When you want to maintain history of time variant data, you have to create a new entity, and you have to have a attribute here with new value and date of change. Like here in this example, we have employee salary, one attribute here in employee table which keep record of his current salary, plus we have another entity, salary history, which is in one-to-many relationship with current employee, with the entity employee. Okay, entity employee just keep record of current data, and historic data record is kept in this salary history table, where we have this salary start date and employee num and salary amount as a attribute, where employee num is a foreign key from employee table, and salary start date is, it's primary key, and employee num is also a part of primary key. Again, here we have another example where we want to keep record of historic data, like employee job history. Like, he has been when he has promoted, his designation has been changed. Okay, so what we can do is we can create a new table with job history, where we assign, like we have job code and employee salary, both we save over here, and here we keep record of job history of employee with respect to this table job history, and it is one-to-many relationship with both employee as well as department. Okay, in order to implement one-to-many relationship, the rule is very simple. You have to add the primary key of one side on the many side as a foreign key, and primary key become parent entity and foreign key become dependent entity. Show it like dependent entity. Like here we have an example, professor and student, they are having one-to-many relationship. So we take the primary key of one side, which is professor side, and professor has primary key prof num, and it become the foreign key in student table. So how to implement one-to-many relationship? You have to add the primary key of one side as a foreign key to the many side. Okay, the fourth design case is about that is called fan traps. Now, fan trap occur when you have one entity into one-to-many relationship with two other entities. So it produces such kind of association among other entity which cannot be represented in the model. It will be more clear if I describe it through an example. Like here in this example, we have a scenario where each division has many players, and each division has many team. Now division is in one-to-many relationship with team, and division is in one-to-many relationship with player. Now the problem here is, like here we show some instances for division. We have two division, U15 and U18. We have two teams, Blue Star and Planters, and here we have the player information. But if you find out which player belong to which team in fan trap situation, you won't be able to find out. Like if I want to see Jordan belong to which team, so Jordan belong to division U18, but we don't know Jordan belong to whether Blue Star or Planters. So this is a kind of incorrect ERD diagram when we have this fan fan trap problem. So it looks like, fan, and we call it fan trap problem. Okay, now this diagram shows the correct ER diagram after solving this fan trap problem, and you can now see that in this case, division is in one-to-many relationship with team, and team is then in one-to-many relationship with player. And now if you can see that if I want to find out Jordan belong to which team, I can immediately find out Jordan belong to planters, and planter belongs to which division? U18. Okay, if I have to find out that which player play for which division, then you might have to first find out the answer of this, that which player belong to which team and this team belong to which division. But still it solved the problem that we have in the previous case when we have fan trap. Okay, redundant relationship is the last design case that we are going to discuss. And a redundant relationship occurs when there are multiple relationship paths between related entities. So the main concern with redundant relationship is that they remain consistent across the model. However, it is important to note that some design use redundant relationship as a way to simplify the design. Like here we have an example for redundant relationship. As we have seen here that in the previous example, division, team and player, like here they have like player have a relationship with division, but it is a transition relationship or transitive relationship, we can say, that is from team. If we want to see which player belong to which division, we have to get this answer through team. But here we can get this answer directly by this, like if we have a new relationship between player and division, then we can get answer of this problem easily, like which player belong to which division. But we can get the answer of same question through team, like we can find out which player belong to which team and which team belong to which division. So this relationship that is between player and division is a kind of redundant relationship. Even if it is not over there, it still works for us, or we can have a solution or answers of our queries. So it is a good design way is to avoid redundant relationship. So even if this relationship is not over there, it works for us. So when possible, we should avoid redundant relationships. Okay, here we have finished this chapter. We have a summary, what are the concepts that we discuss over here. Okay, thank you.